In this video, we're going to build and deploy a chat application that scales horizontally with WebSockets and Upstash Redis. Now, I'm really excited about this video because there's a ton of things to learn, and they're mainly concepts that are going to help you land a job and stick out when you start that job. So I'd like to thank Upstash for sponsoring this video, and Upstash are going to provide the underlying Redis infrastructure that make this possible. Now, Upstash is a serverless data platform that provides serverless Redis, Kafka, and Qstash, and they're extremely easy to get started, and they have a very generous free tier, which we're going to be taking advantage of in this video. So who is this video for? Well, this video is for those that are familiar with JavaScript or TypeScript. I'm not going to be teaching you syntax in this video, rather I'm going to be trying to teach you some concepts. So the features of this chat application are going to be really simple. You're going to be able to send and receive messages, and you're going to be able to show the current count of connections. The reason that I'm keeping this simple is because I want you to take this application from this video, make it your own, and put it in your portfolio to really help you land those jobs that you're after. So what are the things that you're going to learn? You're going to learn how to create real-time communications with WebSockets. You're going to learn how to use Redis PubSub to communicate across multiple instances, and this is the secret sauce to making this scale horizontally. You're going to learn how to use Redis to store data, including the connection count, and you could also do the messages, but we're not going to be doing this in this video. You're going to learn how to use Docker and Docker Compose to containerize the application, and we're going to be using Docker multi-stage builds. We're also going to be using GitHub Actions to automate the CI/CD pipeline. And then finally, we're going to be using graceful shutdowns inside of our Fastify backend. So what are the technologies that we're going to be using throughout this video? So each one of these technologies has been hand selected to be both professional and easy to use. These are the sorts of technologies that you're going to be seeing in production grade applications. So we're going to be using Fastify to build out our backend. We're going to be using WebSockets for our real-time communications, and the implementation of WebSockets that we're going to be using is Socket.io. We're going to be using Next.js for the front end. You don't have to use Next.js. You could use HTML, you could use HTMX, you could even use Vite, you could use Vue, anything that you like really. We're going to be using Tailwind, and we're also going to be using ShadCN UI, and this is just for the styling. We're going to be using Redis for our PubSub. Specifically, we're going to be using Upstash Redis. We're going to be using Docker and Docker Compose for our containerization, GitHub Actions for our CI/CD pipeline. We're going to be using DigitalOcean for hosting our backend. Now, you don't have to use DigitalOcean. You could use another provider like AWS if you prefer. And we're going to be using Vercel to host our front end. To get the most out of this video, I recommend setting yourself up properly and following along with the video. So if you would like to follow along, you're going to need a few things before you get started. You're going to need an Upstash account. You're going to need Node.js installed. You're going to need Docker and Docker Compose installed. You're going to need an editor. I'm going to be using VS Code. You're going to be needing a DigitalOcean account. You could also use AWS. You're going to need a Vercel account. You're going to need the Vercel CLI. And of course, you're going to need a GitHub account. If you need to get any of these things set up, now is a great time to pause the video and go get them set up. So before we get started with any code, I just want to take a moment to diagram this out, because if the first time you see this is in code, it's going to be quite confusing. But if you take a moment to watch this diagramming section, and then we dive into the code, it's going to make a ton more sense. So firstly, let's start with modeling out a traditional chat application. So we have a client here, and this client is just the user interface. So this is the UI. And this is what the user has downloaded to their browser, and they're interacting with our application through this client. So we can call this client 1, and then we could also have a second client, and then we could have a third client. And when I say client 1, client 2, client 3, I just mean these are all the same UI, but there's 3 different people using this application. And all 3 of these users are chatting with each other through a backend. So we have our backend service here. And then when client 1 sends a message, we want it to send to client 2 and to client 3. So we can say here that we send a message, and client 2 and client 3 are going to subscribe to these messages from our backend. And client 1 is also going to be subscribed. Now the mechanism for subscribing to this backend is going to be WebSockets. So we can say that these are all connected via WebSockets. And let's just say this is WS, but we all know that this means WebSockets. Okay, and when we send a message, we're also going to send that message through our WebSocket connection. So we have here our WebSockets, and this is really great. So what this means is that we can both send data to the server, and then the server can send data to the clients. And this is a little bit different to something like HTTP, where we're going to have a request and a response. With WebSockets, we can push data from the server to the client. So our CTO has now come along and said, we have so many users, we need to scale our backend infrastructure here. And because we're using a cloud provider, we want to scale this horizontally. In essence, what that means is we just want to set up more instances of our backend. We don't want to just create a new server of our backend that is a larger instance. We want to get the benefits of using a cloud provider so we can shut down instances of our backend when it's not being used and then scale them back up when we have high volumes of traffic. So now we have multiple instances of our backend. Let's move this up. And in between our backend and our front-end clients, we also now have a load balancer. So let's say that this is our load balancer, and our clients are now connected to the load balancer instead of to each backend individually. So we can say these clients here send messages to this load balancer, and then our load balancer is going to send messages to the backends for us. So our load balancer is going to send messages to this backend. Okay, so now our infrastructure looks like it's going to scale horizontally, but we have a big problem. What happens if client 1 sends a message and it gets consumed by backend 1, but client 2 is actually connected to backend 2 through the load balancer? How are they going to get that message? Because our WebSocket is going to receive the message and then it's just going to emit a message to all the users connected to backend 1, and client 2 isn't in that list. So we need to add another layer here. And this other layer is going to be a pub sub layer. So up here, we can call this pub sub. And in our case, this is going to be Upstash Redis. And Redis is really the go-to piece for this. In most cases, Redis is what you're going to see people using. So what's going to happen? We're going to send a message from client 1. Client 1's going to get that. And then it's going to say to Redis, hey, publish this message here. Now, all these backends here are going to be subscribed to messages from Redis. So these are the subscribed clients, and this client here is also subscribed. Now, when Redis gets that message, it's going to send it out to all the backends that are subscribed, and then these backends are going to emit the message, and then that's how user 2 is going to see the message. So let's have a look at this from a data flow perspective. So we have user 1, and user 1 sends a message to the backend 1. So we can say sends, and the message doesn't get sent directly to backend 1. It does go through the load balancer. I'm just going to model that out here because it doesn't really do much in terms of the data flow. Now backend 1 is going to send a message to Redis. So this is going to publish the message. Now backend 2, because it is subscribed to messages from Redis, it is also going to get the message, and then it is going to emit the message out to user 2. This is going to be emit. It's also going to emit the user to all the backends that are subscribed, including backend 1. So the message for backend 1 is going to go from the user to backend 1 to Redis, then back into backend 1 through the subscription model. Then it's going to be emitted back out to user 1. Okay, so I hope this concept is clear. Let's hit that subscribe button and we can dive into some code. If you have a look in the description below, you're going to see a link to a GitHub repository. Inside of that GitHub repository, you're going to find the finished project. And in that finished project, you're going to see these two files here, this command file here, and this just has all of the commands that I'm going to be using throughout the video. So if you open this up, you don't need to type these out as I copy and paste them into the terminal. You can just copy and paste them from this command file here. So the first thing that I want to do is to create a new folder, and I'm going to call this folder server. Now I'm going to have my server and my user interface all in the one repository. And the reason for that is because I think it's a little bit easier to follow along for you as a viewer if I'm not switching between folders and repositories. So I'm going to open up my terminal and I'm going to cd into my server and I'm going to start running these commands. The first one is pm init. And this is just going to initialize a new package.json for us. The second command is pnpm add, and this is going to add the required dependencies for the server. The next command is going to install the development dependencies, and you can see this -d here. This just means install these as development dependencies. Then this pnpm tsc init is going to initialize a TypeScript config file for us. And you can see here we get this tsconfig file. Before we go any further, let's just change one thing in here, and this is going to be our out directory. So search for outdir, and we want to change this to /build because we want to build this into a new directory called build. If we don't add this, it builds the files in line with all the other files, and it's actually quite annoying. Okay, so these are all the commands we need to run for the server. Inside of our server folder, let's create a new folder, and I'm going to call this src, and this is just where we're going to house our source code. Inside of our src folder, I'm going to create a main.ts file, and inside of our main.ts file, I'm just going to console.log hello from main. Now open up the package.json, and you can remove this test line here, and we can say dev, and this is just going to be our script to start this up in dev. So I can say tsx, and this is going to use the tsx package that we installed as a development dependency. And we want to run this with a watch flag, and then we want to tell it which file we want to run. And this is going to be src/main.ts. So now we can do pnpm dev, and you can see we get hello from main. If we go save this, hello world, you can see that it restarts and it outputs the new contents of this console.log. So the second script that we want is going to be our build, and this script is just going to run tsc. So we can say pnpm build. And this is going to run the TypeScript compiler for us, and you can see we get a new directory here called build, and this is going to have our main.js in it, and then we can run this with Node. Okay, so let's create a new file inside of our server, and I'm going to call this .git ignore, and inside of git ignore, I'm going to add my Node modules. I'm going to add my build directory, and I'm going to add .env, and we're going to create a .env in just a minute. So the next thing I want to do is get all my environment variables set up. So I want to come over to Upstash. I'm going to have a link to Upstash in the description below, and it's going to bring you over to upstash.com. And from here, we can get started. So we can click login, and I'm just going to log in with GitHub. And then creating an Upstash account is just as simple as that. And you're going to be brought over to this Redis section here where we can see our databases. We don't have any databases, and so we can click create database. I'm going to call mine chat. I'm just going to create a regional type, and I'm going to select the region that is closest to me, and that is going to be Sydney. I want to select another read region, and this is just going to be Singapore. Now, I don't want to enable TLS, but you can do that if you like. That's just going to encrypt the data for you. When you do connect to Redis with TLS enabled, there is another option that you need to provide, and I can show you that when we get to that section. I'm going to click eviction because I want to enable the eviction of entries when it reaches a maximum size. Let's click create, and this is going to create your Redis instance relatively fast. So you can see that was only a couple of seconds there. I'm going to copy this URL here, and this includes our username, our password, and the host for us, making it nice and simple. You can see down here, Upstash provides you with a few methods for connecting to your database. So you can use this CLI if you like. You can also use this Upstash Redis module here. We're not going to be using this. We're going to be using a different module called IO Redis. And you can see that they provide that example here with IO Redis for Node.js applications, which is what we're going to be doing. Inside of the Upstash console, you're also going to see this usage dashboard. And because we haven't actually used our Redis instance yet, we have no usage, but this is a really handy dashboard for telling you how much usage you've gone through this month, so you can see if you need to upgrade or if you can stay on the free plan. So another really handy feature is this CLI that's inside of the browser, and this is going to allow you to instantly communicate with your Redis instance. So I can set some data here, and then I can go over to data browser and I can view that data. So let's say set test to testing. So we get an OK message. Now we can say get test, and you can see that we get testing back here. This is actually sending this data to Redis and storing it for us. If we go over to data browser, now you can see test, and you can see the contents is testing. There's also this quick start section here, which is going to provide some really handy quick starts for you to get started with straight away. So if we don't cover what you would like to do inside of this tutorial, you can come over to this quick start section and you can get started really quickly. Okay, so let's go back to details and we can copy our link here again. I want to create a new file inside of our server and I call this .env. Inside of .env, I'm just going to create a new variable called Redis endpoint is equal to, and then I'm going to paste that endpoint. One thing to note is if you do use the Upstash Redis module here, it comes with a really nice from env property, but if you use that, you need to use this Upstash Redis URL here. In fact, let's just copy this here and we can change our environment variable to this. So if anyone would like to use this Upstash Redis package, they can use the from env option. So I'm going to rename this here. Okay, so this is the only environment variable that we need to set for now. Let's start importing these environment variables. So I want to import .env from .env, and we need to make sure we spell this correctly. Then we can run .env.config and execute that. So the first environment variable that I need is going to be a port, because we're going to be running several different instances of this backend to really prove that it does scale horizontally. So I'm going to say const port is equal to process.env.port, or we can set this to 3000. Now I've made this a string here, so we can wrap this in parse int, because port needs to be a number, and I'm going to provide a 10 here, and this is just the radix parameter that tells it that we're going to use base 10, and it's always good practice to provide this parameter here. The next environment variable is going to be our host. So I'm going to say const host is equal to process.env.host or 0.0.0.0. Now we probably are never going to need to set this environment variable. Now we need to use 0.0.0 and not localhost because Docker doesn't know what localhost is. If you do set this to localhost, you're going to experience some problems when you go to run the application in Docker. The next environment variable I need is going to be my cause origin. So I'm going to say const cause origin is equal to process.env.cause origin, or it's just going to be HTTP localhost port 3000. Actually, let's change this 3000 here to 3001, just so we have no conflicts with our UI starting on port 3000. The next environment variable I need is going to be my Redis endpoint. So I'm going to copy this Upstash Redis REST URI. So const Upstash Redis REST URI equals process.env.upstash Redis URI. Sorry, URL, not URI. If we don't have this environment variable set, I just want to exit the application with an exit code of 1, which means we have an error. So let's say if we don't have that in variable, then we're going to console.error missing, and then I'm going to process.exit with a status code of 1. Okay, so the next thing that I want to do is to create an instance of Fastify. So I'm going to do this inside of a function called build server. So I'm going to say async function build server. Then under this, we're going to have another function. This is going to be an async function called main. And then we're just going to execute our main function. So our build server here is going to create an instance of Fastify equals, and then it's just going to return this instance of Fastify. Then inside of our main file, I'm going to say const app equals build server. And this is an async function, so it's going to return a promise. So we need to await that promise. And now inside of our main function, we can start our server. The reason that I like to separate the building of the server from the starting of the server is because if you want to write tests for your Fastify application, you can just import this build server and then you can start injecting requests into that server. And you're not going to run into any weird issues with the server not shutting down inside of your test because you don't actually need to start the server in your test. Okay, so I want to wrap this in a try and a catch block. If we do catch an error, I want a console.error, and I just want to log out that error, and I want a process.exit with a status code of 1. And what we're going to do is await app.listen, and then I want to specify a port and a host. So I'm going to say port, and that's going to be our port environment variable, and then we're going to have hosts, and that's going to be our host environment variable. Okay, so let's try this out, and I actually want to console.log when we start this. I'll say console.log server started at HTTP. Then I want to put in my host and I want to put in the port. So we can run pnpm dev and we get our server starting successfully. So anytime that we build a server, the first endpoint that we always have to add is a health check endpoint. So we can use this to make sure our server is up and responding to requests. So I can say app.get. And I'm doing this inside of build server. Remember, this is going to build the server and register all the plugins and endpoints. And then this main function is just responsible for starting the server. So when I have a get request on /health check, I'm going to have a callback that just returns an object. The status is going to be okay. And I also want to provide the port in here that we're running this instance on, because remember, we're going to be running several instances and I want my health check endpoint to tell me which instance I am connected to. So now we can make a curl request to this endpoint. So I'm going to say curl localhost 3001/health check, and we get back status okay and our port of 3001. So everything is working as we expect. So the next thing that we want to do is to register our cause plugin. And we're going to do this because if we don't do it now, we're going to forget, and then we're going to run into cause issues in production. And it's just the way it always goes. So it's good to get this out of the way first up. So I want to say app.register. Now I want to register a plugin, and that plugin that I want to register is going to be cause. So I'm going to import Fastify cause from @fastify/cause. One of the things that I love about Fastify is that it's extremely predictable. Every single time you register a plugin, it's going to be pretty much the same thing. You're going to say app.register, you're going to provide the plugin that you're going to register, and then you can provide an object of configuration. So in here, I want to provide my origin, and this is just going to be my cause origin. Now register returns a promise, which means we need to await this. So what we're going to do is we're going to say, hey, register this. Once we're finished registering, then we can start moving on. If we don't do this, we're going to run into some issues, especially when we register our WebSocket plugin, which we're going to do right now. So at the top here, I want to import Fastify IO from Fastify socket IO. And I want to say await app.register Fastify IO. And that is all we need to do to get WebSockets working. So now we can start using these. So I can say app.io.on. Now I want to listen to an event called connection. So on connection, I want to provide a callback. Inside of that callback, I'm going to get a property called IO. And then we can use IO to start emitting events. So when we get a connection, I just want to console.log client connected. Then we can listen to another event in here called disconnect. So I can say io.on disconnect. And I want a console.log client disconnected. Now let's go try this out. So I'm going to open up Postman. So inside of Postman, I'm going to create a new request. I want to use Socket.io. I don't want to use WebSockets because Socket.io is the framework that we're using. And I want to send my connection to ws://0.0.0.0 to port 3001. Let's connect. You can see that we get this green circle here and it says connected. Let's open up a new tab and we can connect again. And then we get this client connected because we connected twice. Let's go disconnect from these two clients and we get disconnected twice as well. So Socket.io is working as we would expect. So the next thing we need to do is to create an instance of Redis that we can use. So I'm actually going to create two instances of Redis, one for our publisher and one for our subscriber. Now our subscriber is just going to subscribe and then our publisher is going to do everything else. So I'm going to say const publisher is equal to new, and we need to import Redis. So import Redis with a capital R because it's a constructor from IO Redis. So it's equal to new Redis. And then we can just pass in our Upstash Redis REST URL here. And let's move this down below our check. So TypeScript is happy. We've done the check to make sure it exists. So we're not going to be passing string or undefined. You can see here it is string or undefined. And then we tighten the type to just a string. Okay, so if you chose to encrypt your data, you're going to need to provide an object here. And inside of that object, you're going to provide another object called TLS. And then inside of that object, you're going to say reject unauthorized, and then you're going to set this to true. Now, I'm not going to do this because I chose not to encrypt my data, but if you did, make sure you set this object here, or you're going to get an error when you start your application. Let's copy this down again, and I'm going to call this subscriber. Now we can start using our publisher and subscriber. So the first thing that I want to do is to get the initial connection count. Because our initial connection count is going to be nil, we need to set it to 0 when our application starts up so we can start incrementing and decrementing it. If it is nil, we can't increment or decrement that. So when we build our server, I just want to say const current count is equal to await publisher.get, and then we want to get the property inside of this connection count channel. Then I want to say if not current count, then I want to await publisher. I want to set our connection count channel, and I just want to set that to 0. Now as clients connect, we can increment this by 1. So I can say await publisher.increment, so INCR, and then we can just pass in the channel. And because we're using await here, our connection callback needs to be an async function. Now as clients disconnect, I can do the same thing, but in reverse. So I can say await publisher.decrement. And I want to decrement the property inside of this channel. And again, a disconnect callback needs to be an async function. Okay, so let's go connect again with our two tabs here. And we can come over to the Upstash console and I can say get my chat connection count. And this is going to be 2. Let's go disconnect. So disconnect from both of these, or I can just disconnect from one. Let's do this again. And we have 1. Let's disconnect from the other one. And we have 0. Okay, so I want to show this connection count on the browser when the users are chatting with each other. So they can say, hey, there's 10 people currently connected to this application. So the way that I want to do that is when a user connects, I want to publish out another message and then have all the subscribers listening to that message to say the connection count's been updated, and then they can emit a message to all of their connected clients. Actually, let's rename this connection count channel because it's not a well-named variable. It's not actually a channel, it's just a key. So I can rename all of these to connection count key. Now we want to have a connection count updated channel. So I'm going to say const connection count updated channel. And this is actually a channel because we're going to be publishing to it and we're going to be subscribing to it. So I want to set this to chat and then connection count updated. So our increment and decrement functions return a number here, and this is the new number of connected clients. So let's say const new count is equal to our increment function here, and then this is going to be a number, and we can publish this out. So I can say await publisher.publish. I want to publish to this connection count updated channel. And then I just want to publish the new count. And TypeScript is complaining because we can't publish a number. We need to publish a string or a buffer. So we can just cast this to a string by wrapping it inside of the string constructor here. And let's do the same when we decrement. So here, let's say const new count is equal. Then we can publish this out again. Now we can have these variables named the same because they exist in different scope. If you wanted to give them better names, you could just say, this is the inc results. Then we can use that. And then we can call this the decrement result. And that is probably a better name for those. Okay, so now we need to subscribe to this channel. So I can use my subscriber for that. So just above our health check endpoint, I can say subscriber.subscribe. And I want to subscribe to this connection count updated channel. And we can give this a callback as well. If we have a look at the docs on IO Redis for the subscriber, you can see that you can subscribe to all of these channels. Then you're going to get a callback with the error if you experience an error, and then the count. And this count is the number of clients currently connected to that channel. So let's implement this into our application. So I want to get my error here and then my count. If we do get an error, I just want to console.error, and I'll say error subscribing to, and then I want to print out the actual channel name. So we need to convert these to backticks, and then we can just attach the error here as well. Then we can console.log, and let's just return here as well, so we don't also log this count. And we say count clients connected to, then we can put in our channel name and then follow it with channel. So you can see now that we get a console log, one client is connected to our chat channel connection updated. Okay, so now that we've subscribed to the channel, we're going to start receiving messages. And so now that we've subscribed to the channel, we're going to start receiving messages, and I want to do something with those messages. So I want to say subscriber.on, and we can listen for a generic message here. And then we're going to get a callback. Inside of that callback, I'm going to get the channel, and then I'm just going to get some text. And the text is the contents of the message. So in our case, it's just going to be this number here, which is actually a string. So this is where we're going to get all messages for all channels. And we're going to have another channel later on for actual messages. And so I just want to test to see which channel this has come in on. So I'll say if channel is equal to our connection count updated channel, then at the bottom here, we can return. So we don't actually do anything else inside of this callback. Then I want to emit a message. So I'll say app.io.emit. And I want to emit to a specific channel. In this case, I'm going to reuse the connection count updated channel. And this is going to now be our socket channel that we're emitting to. And I want to emit an object here, and I'm going to say count, and our count is just going to be our text. Okay, so let's grab this property here, this text, chat connection count updated, and we can come back over to Postman. Inside of Postman, you can see events here. I'm going to paste in this event, and I'm going to start listening for this event. So then let's connect. So we're not getting any messages here. Let's go start debugging. And I actually don't think we need to do any debugging. I can see the issue straight away. I've made this a string, and it actually needs to be our constant. So let's remove those string tags, and we can come back over to Postman. Now we can connect while we're listening to this, and you can see that instantly we get our count. Let's connect over here, and we get a new count of 4. Let's disconnect, and we get a new count of 3. So this is working for the most part, but you can see an obvious issue here. The count isn't actually 3. The reason that it's showing us 3 is because when we restart our server, because we save a file here, it's not actually running this disconnect function up here that is going to decrement the number of connected clients for us. Okay, so we can fix this, and the way that we're going to fix it is we're going to maintain a number of connected clients to this instance, And then when we go to shut down our application, because we've restarted it, we've sent a kill signal, say Control C or Command C, then we're going to decrement the number of connected clients by that remaining number. So if that doesn't make sense, just bear with me for a little bit because it is going to be fairly simple. So let's say let connected clients is equal to 0. So this is our starting number of connected clients. When a user connects, so I'm going to say connected clients plus plus, this is going to increment it by 1. When a client disconnects, we can decrement it, so connected clients minus minus. Now when the application shuts down, if this number is above 0, then we need to take that number off the number of connected clients. So how do we know that our application is shutting down? Well, we can use a technique called graceful shutdowns. And the author of Fastify, Matteo Collier, has created a really useful package that is going to allow us to do this. And it's actually a very small and simple package, and it's even simpler to use. So I'm going to import close with grace from close with grace. Now, if we scroll down to our main function, after we start our application here, we're going to run close with grace. And we're going to give this an object as the first parameter. And then we're going to give it an async function as the second argument. Inside of this object, I'm going to have a delay of 500 milliseconds. Now we can do our graceful shutdown in here. So I just want to console.log for now. Shutting down. Now let's save. And you see we get shutting down and then our server restarts again. So this delay here is sort of like a timeout, or at least that's my understanding of what it means. It says the number of milliseconds before abruptly closing the process. So by default, this is going to be 10 seconds, and actually 500 milliseconds is probably not enough. Let's make this 2000. And so if our shutdown process takes more than 2 seconds, then it's just going to kill the application and you've failed your shutdown basically. Okay, so the first thing that I want to do is just run await app.close. And this is just going to close the connection to our application. And then we can console.log, shutdown, complete, goodbye. Now I want to say if connected clients is above 0, then we do actually need to do some work to reduce that number down. So I want to console.log, removing connected clients from the count. Now we need to get the current count. So I'm going to say const current count is equal to await. And I want to get this from my publisher.get connection count key. Or I'm just going to set this to a string of 0. The reason I'm doing that is because this is going to return a string. And so I need to pass that to an int because we're going to be doing some maths on that. So pass int. Again, I'm going to pass in my radix parameter of 10. And VS Code is going to format this for me. It's just going to wrap this in brackets and then do the OR operator here. Okay, so now we need to figure out a new count to set. So I'm going to say const new count is equal to current count minus connected clients. And I actually don't want this to go below 0. So I want to wrap this in a math.min because there might be some scenario where this connected clients is a number that's higher than our current clients. And in that case, I just want to have the best possible scenario. And that best possible scenario is that we just set it to 0. And this actually needs to be math.max. So if this is a negative number, then the max value is going to be 0. Okay, so the last thing we need to do is to just set this new value. So I'm going to say await publisher.set connection count key, and then I want to set this to new count. Okay, so now we can come back over to Postman and we can connect with our two clients. We can come back to Upstash. We can say get, and then we want to get our connection count, and it's going to be 2. Let's go back over to VS Code, and we can save this file and force our server to restart, thus forcing it to run this shutdown. So we can save this, and you can see we're removing 2 clients from the count. And I've also logged out here the signal, any errors, and you can use this manual function as well. We're just going to remove that. Then let's go back over to Upstash. Now we can get this count again, and we're back to 0 as we would expect, because our clients here have actually disconnected. You can see we didn't click disconnect, but they have disconnected. This might look like an issue, but on our client, we're going to have a property for reconnecting. So our client is going to handle that reconnection automatically. It's going to connect to a different instance if there is a different instance available. And then it's going to increment that number again, and the client is going to be unaffected. They're not going to know that they disconnected and reconnected. Okay, so let's clean up some of these console.logs so we're not spamming ourselves. And the next feature that I want to implement is going to be our messages. So I want to be able to send a message, and then I want to publish it out to Redis, and then I want to have Redis subscribe and then emit those messages out to all the different clients. Okay, so the first thing that I want to do is to create a new constant for our new message channel. So I'm going to say const new message channel is equal to chat new message. You can name this whatever you like. It doesn't really matter. If you want to persist messages in your application, you can create another channel now, or a key. So I can say const messages key is equal to, and then I would call this chat messages, and then I would persist these messages here. So if you want to send these in a room, then I would also add the room prefix here as well. So let's just say, for example, we had function send message to room. Then we'd have an object here, we'd have the room, and then we would have the message contents. Then my channel would be named chat room. And then I would be able to send a message to this room. So actually I would call this room and then messages. So that's how I would persist messages in a room. Let's remove this. So I want to come back down to app.io.onConnection, and I want to start listening for messages. So I want to say io.on. So you could use any string here. So I could call this new message, but I'm just going to reuse the new message channel. And this is out of pure laziness more than anything else. I just don't think that you need another channel just for your socket stuff. I think it's okay to reuse the channels between sockets and your publishers, because after all they are is just names of channels. Okay, so you're going to get an object here, and you're going to get the message. Now I want to publish this to a Redis channel. So I'm going to say publisher.publish, and the channel that I want to publish this to is going to be the new message channel. And then we're just going to have a message, and I'm going to call .toString on this message. The reason I'm going to call toString on this message is because this message is actually going to be a buffer, and we need to convert it to a string. And you can also make this an async function and await this if you like. Now we're just going to repeat the process that we did with our subscriber down here. So we're going to have subscriber.subscribe. New message channel, then we're going to get our callback. One thing that you can do is you can just chain the channels up here. So you could do that, and that's perfectly fine. I want to separate these out here just so I can have a different log. So I can say if error, then I want to say console.error, error connecting, or error subscribing to, and then I want to have the channel. And I also just want to return here. I don't want to log anything else, just like we did up above here. Then I want a console.log the count clients connected to this channel. And let's rename connected here to subscribed, because connected and subscribed mean different things. Subscribed sort of implies that you're pushing the data to that client. A client that's connected could push the data itself. Okay, so we need to come down to subscriber on, and I want to do another test in here. So I want to say if the channel is equal to new message channel. And we're not going to make this a string like last time. We've learned our lesson from that. And I want to return out of here as well, just in case you have some other subscriptions going on in your application. I'm going to app.io.emit. And again, I'm going to reuse this new message channel. Now I'm going to emit an object. So the text I want to emit is going to be this text here. So I'm going to call this message. I'm going to give this text. And I also want to attach an ID. And this is just going to be a random UUID. Random UUID comes from the crypto package. You don't need to install anything else to be able to use this. The reason that I'm going to attach a random UUID is because in our React app, I want to map through these messages and I need to have a key that I can guarantee is unique. I also want to have a created at. This is going to be a new date. And I want to have the port that the client was connected to when they received that message. So this port here, or this data here, is generated by the instance of the application that that client is connected to. So let's say we have 10 clients connected to 2 instances of our application. Some of those clients are going to get a different ID to the other clients because this ID is just going to be generated individually on each instance. If you didn't want that, if you wanted all the messages to have the same ID, then you would need to generate this data here, up here, and you would need to push it into Redis. So you would need to do that here. But I'm not going to do that because I want to see which instance the client receiving the message is connected to. Okay, so let's come up and we can grab this channel name here. So chat new message. Now we can head over to Postman and we can connect both of our instances here. Now we can come into our message section and I can paste in here the name of the message. Now we can compose a new message. So if we go back actually, and we can have a look at what it is that we're subscribed to, you can see that we have an object here and the property inside of that object is called message. So we need to reconstruct that in Postman. So I'm going to give this a key of message and then I'm just going to say hello from client 1. Now let's send this. So when we send this message, both of our clients are disconnecting and it tries to send the message, but it never ever receives the message, which looks like we probably have an issue. So let's go have a look and our server looks like it's running okay. So my guess is that the issue is somewhere here. So we can comment out this publisher and I want to remove this object here because we may be trying to get message out of null. And I just want to say rest. And then I just want to console.log when we get this message. So let's try send this. It's going to connect. And it's going to send the message. So let's go back. So it looks like we get one property here and it's all just one big string. So let's try message and we can log out this message. Just having another look here, the reason is because we have text selected here. Let's select JSON and we can send this. Now we get an object with message, so we can deconstruct this message here. In fact, let's not deconstruct that. Let's say this is payload and we can say const message equals payload dot message. Now we can say if not message, then we're just going to return. So this is going to be a little bit safer. Let's uncomment this publisher here. Let's go back to Postman and we can connect again. Let's send this message. So we've sent the message. Let's connect over here, send another message. And you can see that we get nothing. The reason for that is because we're not listening to any events in our second client. So we can fix that by getting this channel here. We can come over to our second client. We can add this event, start listening for that. And let's also listen in this client as well. Let's send this. And you can see that our second client has received the message. We got a UUID and we have a created at date and we have a port. Okay, so the ID here and the ID here are exactly the same. And the reason for that is because we only have one instance of our application running. Let's go test this with multiple instances. And to do that, we're going to start it up inside of a Docker container. So to set up Docker, we need to create 4 files, and we can create these files inside of the server directory, or we can create them inside of the root of the application. I'm going to create them in the server directory just because it makes a little bit more sense. This is for setting up the server. So the first file that I'm going to create is going to be our Docker file, and this is going to tell Docker how to build this container. The next file is going to be our Docker compose.yml, and this is going to automate the creation and the starting of these containers for us. The next file that I'm going to create is going to be my Caddy file, and this is going to be the configuration for Caddy, which is going to be our web server and load balancer. Then the fourth file that I'm going to create is just a run.sh, and this is just going to be a little script that we can use locally to start the application up really easily. So I'm going to add the run.sh to my git ignore, because we're going to include some secrets in there and we don't want to commit this. Okay, so let's start with our Docker file. And as I mentioned in the start of the video, this is going to be a multi-stage build. So the step 1 is going to be build the base. Then let's call this stage actually. Stage 1 and stage 2. And stage 2 is going to be to build the app. And then the third and final stage is going to be stage 3, and this is going to be production. So this is going to be starting up the application. Okay, so I want to start with a base image, and that base image is going to be Node version 18, and I'm going to use the Alpine version just because it's a little bit smaller. So I'm going to say from, and I want to get this from Node, and I want to get this from 18, and then I want to specify the Alpine version. And then I want to say as base. Then I want to set a working directory. So I want to say work directory, and I'm just going to set mine to /app. Now I want to copy in the files that we're going to use to build this application. So I'm going to copy in the source directory to /source. So that is just this directory here that includes this main.ts file. I'm going to copy the package star.json to /. So this is just going to copy into the root of our working directory here. I'm going to do the same with our tsconfig file. So copy tsconfig star.json, do /. And this is tsconfig. Then I'm going to run a command. So I'm going to say run, and the command that I'm going to run is npm install. Now you could install pnpm and then use pnpm, but I'm just going to use npm because it's simple. Okay, so that's stage 1 done. Now stage 2 is going to build the application. So I'm going to say from base. So we're going to start where we left off from our base as build. Now I want to set my working directory again to /app. And I'm just going to run a command. And the command that I'm going to run is npm run build. So npm run build. So if we run this in the terminal, we can say npm run build. And you can see that this is just going to run tsc, which creates our build directory for us. Okay, so to start the application, I want to use my base image again. So I'm going to say node 18, and I want to use the Alpine version. I want to set the working directory to /app again. And I want to copy in the package.json again. So I'm going to copy that. I'm going to paste it down there. Then I want to run npm install again. So I'm going to run npm install only production. And this is just going to install our dependencies that aren't development dependencies. If we have a look in the package.json, you can see we have these dependencies here, and then we have development dependencies. /only production is going to install only these dependencies. Okay, so now I want to copy from, and it's going to ask us for a stage that we want to copy from. I want to copy from build, and I want /app/ build, and I want to copy it into the root of that directory. The next thing I want to do is to run a command. So I'm going to say cmd, and I'm going to give this an array. The first argument is going to be node, and then I'm going to tell node what to run. So that is going to be a main.js. Okay, so the next file that I'm going to work on is going to be my Docker Compose file. So I'm going to specify a version, and this is the version of Docker Compose that we want to use. I'm just going to be using version 3. The next thing I want to specify is the services that I want to start up. So I'm going to say services, and I'm going to call my first service chat app 1. Then I need to specify the build, and I want to pass a few arguments in here. So I want to set the context here to just dot, which means the current working directory. Then I want to specify a Docker file that I'm going to use to build this application, and that is going to be this Docker file here. So I can say this is going to be Docker file. Now I need to set some ports to expose. So I can say ports, and I want to expose port 3000, and I want to expose that on port 3000. Actually, this is 3001. So what this is saying is, inside this container, we have something running on port 3001, and I want to expose that to the external port of 3001 as well. You could make this 3002, and then your application would be available on 3002. Then I need to specify some environment variables. So if we go to environment, and you can see here that we specify a name and then a value. I'm just going to split my window with main here so we can see what the environment variables are that we have set. So we have a port, so let's set that to 3001. We have a host, but we also have a good default here for a host, so I don't need to specify that. We have a cause origin, and I want to set the cause origin from an environment variable from my local system. So I'm going to say that's equal to a $sign and some curly brackets, and then it's going to be cause origin. And then we have our Upstash Redis REST URI, and that again is going to be set from an environment variable. Okay, so we have one instance of our chat app running, but we want to run several instances because we want to prove that we can scale this horizontally. So let's copy this. And I'm going to move my cursor back to the starting line here, and then I'm going to paste it because these two need to line up. And then we can call this chat app 2. I want to change the port here to port 4000. And then it needs to run on port 4000 as well. Let's copy this. And I'm going to call this chat app 3. And this is going to run on port 5000. So I need to expose port 5000. Okay, so we have our 3 services here. If we collapse these, you should see them all lining up like this. YAML can be a little bit fiddly, but if everything lines up like this, it should be okay. Okay, so I'm going to create another service, and this is going to be Caddy. Now I want to specify an image for Caddy, and this is going to be caddy/caddy 2.7.3. And again, it's going to be the Alpine version. I want to say the container name is caddy server. I want to specify restart unless stopped. So keep restarting this container unless we specifically say to stop it. We need to expose some ports. So I'm going to expose port 80, and I'm going to expose that to port 80. And I'm also going to expose port 443. And again, I'm going to expose that to port 443. So port 80 is obviously for HTTP connections, and port 443 is for HTTPS connections. We are going to get a self-signed certificate from Caddy for free. Okay, we need to specify some volumes as well. So I'm going to say volumes. And the first volume that we need to specify is $pwd, which is the present working directory /caddy file. And that is this caddy file here. So we're going to put some configuration in here, and we need to put this into our container. And I want to put that into /etc/caddy/caddy file. Then I want the present working directory /site, and I want to put this into :/srv. Okay, so now we need to configure our caddy data and a caddy config as well. So caddy data, and that is going to be in a data folder. Then we're going to have caddy config, and that's going to be /config. Now we need to create these two volumes here, and that is as simple as going to the start here. So we have no indentation, and we can say volumes, and we want to specify our caddy data and our caddy config. Okay, so the next thing to do is to configure our caddy file. So I just want to run this service on a local host for right now, and then we can run it on an actual domain later on. So the host that I want to run this on is http://127.0.0.1. And then caddy is going to listen on this address, and we need to tell caddy what to do. So what we want to do is reverse proxy, and we want to reverse proxy to our Docker containers. So if we open up this caddy file here, you can see the containers that are going to be running. We're going to have chat app 1. So we want to reverse proxy to chat app 1, and that is going to be on port 3001. We also want to reverse proxy to chat app 2, and that is going to be on port 4000. Then we also want to reverse proxy to chat app 3, and that's going to be on port 5000. Now I want to specify one header here, and that is going to be header down, and this is going to be our strict transport security, and this is going to help us get an A+ rating in our SSL certificate. So we can say strict transport security, and then we're going to set a max age here to 31536000. So the next file that we want to edit is going to be this run.sh, and this is just going to be a little script that we can use to build our application. So I want to export, and I want to export an environment variable. So the environment variable that I want to export is going to be this Upstash Redis URL. So I'm going to say Upstash Redis REST URL equals, then I'm going to copy this from my .env file, paste that in there, and we can also export a cause origin. And let's just set that to HTTP localhost port 3000 for now. So when we build out our application, we can actually use the server that's running in Docker. Now I want to run the command docker compose up. So docker compose up, and this is going to tell docker compose, hey, run this compose file here. Now I want to run this with the detach command, which means it's detached from the terminal that we run it in. And I also want to run this with a -- build flag, which tells Docker Compose to rebuild the image every time. Okay, at the start of this file, I want to Docker Compose down. So Docker Compose down, and this just tells Docker Compose, hey, take down any of the services that we've started up with this Docker Compose file. Okay, so make sure you're in your server directory, and we need to mod this file. So we can say chmod +x run.sh, and this just tells our file system that we have permissions to execute this file. Now we can run run.sh with /run.sh, and we get this error here, chat app 1 ports must be a list. So if we have a look at our Docker Compose file, you can see that we need a space here between the dash and the actual ports that we specify. Let's make sure we have done this with all of our services. And let's try this again. And so Docker is going to start building these containers for us and starting them up. Okay, so we can see Docker has finished here. And if we open up the Docker desktop app, you can see we have our server running here. We can open this up and all of our services are running correctly. One thing I'll note is in the caddy file here, if you want to turn debug mode on, you can open up some brackets and you can just say debug, and then you can run your build script again. So /run, and this is going to start caddy up in debug mode, which is going to give you a more verbose log. So if we go into caddy, you can see here that everything looks fine. We have no error logs or anything. Okay, so we can test this out. If we go over to our caddy file and we copy this URL here and then open up Postman. Now we can make a new HTTP request to this endpoint here. Make sure you don't have an S. We don't have a certificate for this URL. And we want to send this to /healthcheck. Now, if we send this request, you can see that this was served from the application running on port 5000. If we send this again, you can see we get this one from 3001. And this just means that it is distributing the load across those 3 instances of the application that we have running. So this all looks good. And the next thing to do is to build out the front end. So if you open up this CMD file here, you can see that we have some commands to run for our UI. So we have our server commands here, and now we have our UI commands. So I'm going to run pnpm create next app, and I'm just going to call this app UI, and make sure you do this in the root directory if you're doing this all in one repository. You don't want to create the UI inside of the server directory. You want to create it in the root. So I'm going to select yes for using TypeScript. I'm going to select yes for using ESLint. I also want to use Tailwind CSS, and that is going to enable us to use the shadcn UI. I also want to use the source directory. I don't want to use the app router, and I don't want to customize the import alias. Okay, so now that we've created our UI, we can cd into UI and we can start installing some dependencies. So I'm just going to copy this pnpm add command here. I'm going to install my development dependencies. Now I'm going to initialize the shadcn UI. You obviously don't have to use this UI, and we're not going to use many components for it, but it is really easy to get started with. And so I do recommend using it. And it also allows you to make really nice user interfaces quite easily. And I want to select yes for TypeScript. I'm just going to select the default, and the color is going to be slate. And my CSS file, if we have a look in our source directory and in styles, you can see it's in there. So I need to change this path to src/styles/global.css. And I do want to use CSS variables. I'm going to set up my Tailwind config in the root directory. It should already be here, which it is. My import alias, I'm going to leave as @/components. Same as my utils. I'm not going to use React Server components, and then I'm happy with this configuration. All that this CLI does is basically make this components file here, which means that we can run add commands. It also configures our Tailwind config for us, and it also puts some stuff inside of our global.css. And I've actually spelt global wrong here. So it should have been globals. So I'm going to copy the contents of our global.css, and then I'm going to put that into globals. And then I'm just going to delete our global.css. Okay, so the next command we want to run is to add some components. So I'm going to run npx shadcn UI with add, and then text area, button, and a form. So if you have a look at the components directory now, you can see we have a button, a form, a label, and a text area that we can use inside of our application. Okay, let's run pnpm dev and just make sure that this is up and running. So we'll come over to localhost port 3000. And you can see that we have a next application here, which is exactly what we want. Okay, so let's go to our pages and then our index file here. And I'm just going to remove everything inside of main. Actually, I'm going to remove main as well. And then I'm going to specify a new main. I'm also going to remove this inter, and I'm going to remove all of these imports as well. So I want to define a custom hook for sockets first. So I'm going to say function use socket. Then I'm going to define a state parameter. So I'm going to say const array equals use state. And I want to default this to null. And I can type the generic out here as a socket or null, and socket is a type that comes from the socket.io client. So I can import the type here, socket.io client. And I'm going to name this socket and set socket. Okay, so at the end of this function, I just want to return the socket. Then I'm going to have a use effect hook with a callback, and we need to specify a dependency array. So I'm going to say const socket IO is equal to IO, and IO comes from the socket.io client. And I don't want to import it like that. I want to import this as the default import. So the first property that we need to set is our socket URL. So I'm going to say at the top here, const socket URL is equal to next is equal to process.env.next public. And we need this next public prefix because we want this to be a public environment variable. If we don't have this prefix, then next is not going to allow us to use this on the client. So I'm going to say socket URL, or I'm just going to set a default here of WS, and then I can set this to 127.0.0.1, and then we have caddy listening on this URL. So now I can use this inside of the first argument of our IO function here. Then we can provide an object. So I want to set this reconnection to true. And this is just going to allow reconnections, which is exactly what we want. I also want to set upgrade to true. So if we have a look at the description for here, it says whether the client should try to upgrade the transport from long polling to something better. So we do want to set that to true. I also want to set my transports here to an array, and I want this to be web socket, and I also want it to be polling. Now, once we have our socket IO variable here, I want to set socket to socket IO. And then I want to provide a callback function, which is essentially a cleanup. So I want to return function, and I want to call socket IO.disconnect. So when we unmount this component, I want to disconnect the socket. So in our home function here, we can now use this hook. So I can say const socket is equal to use socket. And in a use effect hook, I can start using my socket. So I can say socket.on connect. Now I want to provide a callback. I can just say console.log connected to socket. Let's go back over to the browser and make sure that we get this log here. So you can see here we get connected to socket. Let's go over to our network panel and we can click WS here, which is WebSockets, and refresh. And you can see that we do get this connection here to socket IO. And we're getting some messages as well, which is exactly what we want. Let's open up our main.ts file inside of our server, and I want to copy these constants here so we can use those in the client. So we don't really need this connection count key, but we do need these two channel names because we reuse these for our sockets as well. Okay, so I just want to create a little form so we can start sending messages with it. So I'm going to say form. And I'm going to have a submit handler. So on submit, I want to call a function called handle submit. Now I want to call this function when you submit the form. I want to have a text area, and I'm going to use the shadcn text area. I'm going to give this a placeholder of tell us what's on your mind. My value is going to be new message, and I need to define this new message variable, and I'm just going to use a state parameter for this. So const equals use state. I'm going to default this to an empty string. I'm going to call it new message and set new message. You could use a proper form library for this if you'd like, but I think this form is so simple that using state parameters is probably perfectly fine. Let's provide a change handler to this that takes an event and calls set new message with our event.target.value. And I also want to set a max length here of 255. Inside of our form, let's have a button, and this button comes from our component /UI/button. And then I'm just going to give this a label of send message. Okay, so we have our text input here and a send message. So this looks pretty bad. Let's go style this a little bit just so it's easier to see. So on my main tag here, I'm going to give this a class name of flex. I'm going to make it flex column. I'm going to give it a padding of 4. I'm going to make its width full. It just means make the width 100%. And then I'm going to give it a max width of 3XL. And then I'm going to say margin auto. So what this is going to do is it's going to give it a width of 100%. And then it's going to give it a max width of whatever 3XL is. Let's say it's 1200 pixels. And then it's going to give it a margin on the left and right of auto, which means it should now be in the center of the page. So you can see here, it's got its max width and it's in the center of the page. So let's add some classes to the form as well. So I'm going to give this a flex. I'm going to give it an items center. Then on our text area, I'm going to give this a couple of class names as well. I'm going to say rounded is going to be large. So I want a large border radius on this. And I want a margin right of 4. And on our button, let's give this a class name of h full. So this is just saying take up 100% of the height of the container. Okay, so this is looking a little bit better. Let's go handle the submit, and then we can get a list of messages, and then we can style that list of messages as well. So handle submit is really easy. It's going to take an event, and that event is of type form event. Now I want to prevent the default behavior. So on e.prevent, and the default behavior is to refresh the form. It's going to try submit it to an URL. Now I want to set new message back to an empty string. So I want to reset the text box when you submit the form. And then I want to emit a message. So I'm going to say socket.emit. I'm going to emit to my new message channel. Then I'll want to emit an object. And this is going to have our message, and our message is going to be the contents of new message. Okay, so let's subscribe to these messages as well. So then we can open up 2 windows and we can see them come through. So subscribing is just as easy. I want to provide a state parameter to store the messages in. So this is going to be a use state. And it's just going to be an empty array. I'm going to call it messages and set messages. And then inside of this use effect, I'm going to say socket.on new message channel. So when we receive a message on new message channel, then we're going to have a callback. And we're going to get our message. So if we go have a look at our server, and we can have a look at what the server is going to emit in terms of a message. And it's going to emit this payload here. So let's go type that out just to make it a little bit easier. I can call this message, and now I can create a type at the top here. So type message is equal to an object. We're going to have our message, which is going to be a string. We're going to have our ID, which is going to be a string. And created at and port are all going to be strings. Okay, so now I just want to append this method to the start of our messages state parameter here. So I can say set messages, and I'm going to give this a callback. Now this is going to have our previous messages. And I want to return a new array, and I want to spread the previous messages, but I also want to put in our new message. And TypeScript is complaining. So let's type our state parameter here. So I want to say that this is an array of message. Now TypeScript should be happy. And let's just go list out these messages above our form here so we can see them when we get a new one. So I'll say messages.map. I want to get my message, provide a callback, and I want to return a list item. I want to provide the text. And I also need to give this a key of m.id. And let's say that this is an ordered list. So let's go back over to our client, send a message. Okay, so when we're sending a message, we can have a look in the WebSocket section here, and we can open up our WebSocket, and you can see that we are sending the message. This is working fine, but it looks like we're not receiving the message. So let's have a look at how we might be able to debug this. So I'm going to come over to Docker, and I'm just going to shut all of this down. Then I'm going to come over to the UI and I'm going to change the URL here to WS 0.0.0 and then 3001. Now I'm going to start my server back up. So cd server pnpm dev. And let's refresh. And you can see here we're getting an error when we try connect to our WebSockets. So let's go over to our UI again and let's try localhost. And I'm just trying to isolate where the problem is. Is the problem on our client or is the problem with our server? Is our server doing what we expect it to do? Let's go refresh and you can see we get connected to socket. Let's type a message, send this message, and this is looking like it's sending and receiving the messages. So we can say that the problem isn't with the client, it's working as expected, and the problem isn't with the server either. So the problem is probably somewhere with Caddy or our Docker file. Okay, so let's stop this and let's start the server back up inside of Docker. So we can run /run. This is going to start our containers back up. And we can replace this URL here to try again. So we need to make sure that we get the URL correct. So let's go over to our Caddy file and I'm going to copy this and I'm going to copy the 127. We don't want the HTTP part. That's not the protocol that we're working with. Let's paste that in. Now I'm going to go back over, refresh. We're getting connected to socket. Let's type a message and it's working. So my guess is that I had the URL incorrect before. So this is sending it through our Docker container and everything is working correctly. Okay, so before we deploy our application, there's a few things that we need to do. We need to style it so it looks a little bit better. We also need to scroll down to the bottom of the messages list when we receive a new message. And we also need to show the count of currently connected clients. So I want to add a H1 here and I'm just going to say this is chat. And then in the H1, I'm going to add some class names. To this, I'm going to add text for Excel, font bold, text center, and a margin bottom of 4. To our ordered list here, let's add some classes. Let's say this is going to be flex1. I'm going to say overflow Y is scroll. So on our top to bottom, we want to be able to scroll through that messages list. And overflow X is going to be hidden. So let's make our window small. And we can send a bunch of messages and you can see that we're starting to get a scroll bar here. On each message, let's add some styles. So on our line item here, I'm gonna add some class names. I'm gonna add a background of gray 100. Rounded is going to be large. Our padding is going to be 4. A margin on the y-axis of 2. And I'm going to say break all. I don't want text to go spill off the side of the screen. And let's also add a p tag here for the created at date. So I'm going to say message.createdAt. I'm going to add some classes to this. So I'm going to add text is going to be small and the text is going to be gray 500. And let's do the same for our port. So you can see here we get a date and we also get a port that the message was received on. Let's open up a new window and go to 3000 as well. And so we can send a message and you can see this client was actually connected on port 3001 and got this message. Let's send them back. So we know that this is sending the messages to port 3001, but then this client here received it on port 3000. So our application is working as we would expect. Okay, so I want this text input here to sit at the bottom of the screen at all times. So I want my message input here to sit at the bottom of the screen. And the way that we can do that is give everything a height of 100% and then make our message list here a flex of 1, which means take up all of the remaining space. So what we can do is we can come over to our globals.css and I can say HTML body and my next element with a ID of _next, and then my main element. And I want to apply a style to this. So I can say @apply, and I want to apply h full. Now you can see our message input sits at the bottom here. Let's put in a bunch of messages. And you can see that we're starting to scroll, so we can scroll through these messages. But I want this to automatically scroll to the bottom when we receive a new message. So we can do that fairly easily. So I need to define a ref. So I can say const message list ref is equal to use ref. And this is going to be a HTML OL list element or null, because it's going to default to null. Now we can go attach this ref to our ordered list. So I can say ref is equal to this ref. Now I want to create a function to scroll to the bottom of this list. So I can say function scroll to bottom. And I want to say if message list ref dot current, then message list ref dot current dot scroll top. Is going to be equal to message list ref dot current dot scroll height. And then I just want to plus 1000 on here. Okay, so when we receive a new message, then I want to execute the scroll to bottom. Let's go try this out. And I can make this shorter here. So you can see that it is scrolling, but we're not seeing the current message. We're still, so you can see that it does scroll, but we've actually appended the new message to the start of the list. So it's going to be at the top. When we receive a new message, let's append that to the end of our messages list. Now we can try that. So I'm going to say hello. And it does scroll, but doesn't scroll right to the bottom. We can fix this with a little trick of using a set timeout with a value of 0. So I can say set timeout. Give this a callback, and I'll give this a 0. Now we can move our scroll to bottom in there. And I can say hello to, and you can see that you can see hello to. The reason that this works is because it moves this scroll to bottom to the next tick of our event loop. So it's not going to be on this tick of our event loop. So we're going to set the messages, and then we're going to scroll to the bottom. So it's a little bit of a confusing trick, but it does work. Okay, so let's now see our count of connected clients, and then we can deploy our UI. So I'm going to define another state parameter for this. This is going to be use state. We're going to initialize this as 0. I'm just going to say this is count and set count. Inside of our use effect, where we're using our sockets, we can say socket.on, and we can use this channel at the top here, connection count updated channel. Now we're going to get our callback here. Inside of our callback, we're going to get an object with a count, and our count is going to be a number. And then we can set count to that number. So we need to name this connection count something different, actually. So let's say this is connection count and set connection count. The reason for that is because we're using the variable count here. And actually need to get the value here. So that's going to be count. Now we can set connection count to our count. Now we can display our connection count, and I'm just going to display this in the title here like that. So I've done something wrong, and this needs to be a colon because we're defining the type here, not another variable. So you can see that we have our connection count here. Let's open this up in a new tab, and they both go to 2 as we would expect. So open up a new one, and let's close this one, and they both go to 2, close that one, and it goes to 1. Okay, so if you have the Vercel CLI installed, deploying your UI is going to be really simple. So I'm going to cd back, and I'm going to cd into my UI directory, and I'm just going to run Vercel. And I want to set up a new deploy. I'm going to call mine Realtime Chat. I want to create this in the scope of my personal account. I don't want to link to an existing project. I'm going to name mine Chat. And the code is located in /, and that's because I'm running this in the UI directory. Okay, so I'm happy with these settings. So if we come over to Vercel, I have this new application here, and I need to go into settings, and I need to set an environment variable. So that environment variable is going to be next public socket URL. And I'm going to set this to WSS because we're going to deploy our server on a secure connection. And I'm going to deploy mine to api.chat.tom.does.tech. Now we can save this and let's go have a look at deployments. You can see that we have this one deployment here. Let's visit this. And you can see that we have connected to a socket, and that socket is 127, and that's because we have the backend running locally. So let's trigger another build so we get the new environment variable. So I can say vercel --prod, and this is just going to create our deployment and push it straight up to production. While that's running, let's go configure our domain. So inside of Vercel, I want to come over to the deployments, and I want to come over to settings, and I want to click on domains. And I want to add a new domain. So I'm going to be hosting mine on chat.tom.does.tech. Now this is going to give us a CNAME that we can use. So I'm going to copy this CNAME here, and I'm going to come over to Cloudflare where I have this domain hosted, and I'm going to click on DNS. I'm going to click add new record. I'm going to name it chat, and then I'm going to put in the IP address, and I'm going to select CNAME. So the target is going to be cname.vercel.dns. So make sure you have proxy turned off. We don't want to proxy this. We're going to be using our own load balancer and web server. So click save. So you can see that Vercel was really quick, and we should be able to access our chat application now on this chat.tom.does.tech. And let's have a look at our WebSocket connection, and it should have failed. So we're trying to connect to this backend, which doesn't exist. So let's go deploy that now. So deploying the server can get a little bit confusing, but if you do get lost, come over to this CMD file here, and this has all the commands that you're going to need to deploy the server. So the first thing that we want to do is to create some keys. So you can do this with the command line if you like, but I'm going to do that with this website here, just so it's a little bit more visual and easy to see what's going on. So this is going to be WP oven. I'm not going to set a password, but I am going to set the length to 4096. I'm going to click generate key. Okay, so I'm just going to leave this open for now, and I'm going to go over to digitalocean.com. And once I've logged into DigitalOcean, I'm going to create a new droplet. I'm going to create my droplet in Sydney just because that's the closest to me. Then I'm going to go down and I'm going to create an image from the marketplace. And I want to create an image from the marketplace, and I'm going to get the Docker image here just so I don't have to install Docker myself. It just makes it a little bit quicker. Okay, so I don't want the premium AMD, I want a regular SSD, and I can come all the way down to the $6 a month plan. Now for my SSH key, I want to create a new SSH key. And if we come back over to the website that we were on before, we want the public key. So come down where it says public key, copy this and paste this into the key section. And I'm going to call this chat. Now click add key. So you'll want to save this private key here somewhere safe. Put this in the repository. Don't commit it to GitHub, but save it somewhere safe, and you can use this to connect to your DigitalOcean droplet. Let's come down. I want to rename my droplet to chat, and we can create this droplet. Okay, so while our droplet is being created, I want to come over to github.com. I'm going to create a new repository. And I'm going to call this chat tutorial. I'm going to make this a public repository. If you do make it a private repository, you're going to need to get a personal access token because we need to clone this repository onto the server. You can do that in the settings of your GitHub profile, but mine is going to be public. We can create that repository and then we get some instructions to push our code up. So the first thing we need to do is to initialize our repository. So in the command line, when we're in the UI folder, let's rm-rf.git, because when we install Next, it's going to create a Git folder for us. So let's cd now back into the root of directory and we can type git init. And we can go over here and we can have a look at the files that have been initialized. So this all looks perfectly fine. The next thing we want to do is to add the file. So we can just do git.add, and then we want to commit. So we can say git add dot, then git commit -m, and I'm just going to commit it with this message first commit. Now we need to set our branch to main. Then we need to set our origin to this repository here. And then finally, we can push our code up. And once our code has been pushed, we can come over to GitHub and we can refresh and you can see all of our code here. Okay, so let's go back to DigitalOcean and you can see our droplet has finished being created. Let's copy this IP address here and I'm going to come back over to my DNS provider. In my case, this is Cloudflare. And I'm going to add a new record. I'm going to add an A record and I'm going to call this api.chat. And then I'm going to paste in the IP address of my droplet. Again, I don't want to proxy this. Okay, so let's click into our droplet here and we can click on access and then we can launch the console here. Okay, so now I have console access to my droplet. So the first thing I want to do is to update the package metadata. So I can say sudo apt update. And this is going to take just a little while. And now I want to install Docker Compose. So I can say sudo apt install Docker Compose. We don't need to install Docker because we already have that installed with this droplet. So I'm going to come over to GitHub and I'm going to click HTTPS and I'm going to copy that URL. And then I'm going to type git clone and then I'm going to right click and paste in the URL. Okay, so now we can ls and we can see that we have chat tutorial here. So the next thing we need to do is to update our caddy file. So in our caddy file, I'm going to change this URL to api.chat.tomdoes.tech. If you experience any problems, make sure you have this URL correct. Now I'm going to say git add dot git commit update caddy URL. Then I'm going to push that change. Then let's go over to GitHub and I'm going to go to settings. Now I'm going to go down to secrets and variables and I'm going to click actions. Now I want to add a few secrets here. The first secret is going to be our cause origin, and this is going to be where our chat application is hosted. So that is going to be this chat.tomdoes.tech URL. You'll need to obviously replace that with your URL. The next environment variable is going to be our Upstash Redis REST URL. So let's click add that. And we can copy that from our .env file. Now we can see if we're missing any environment variables, because if we come over to our Docker Compose, and you can see that we're only getting 2 from environment variables. The rest are hard-coded inside of the Docker Compose file. So it looks like we're good for now. So in the root of the project, let's create a new folder, and I'm going to call this .github. Inside of .github, I'm going to create a new folder called workflows, And inside of workflows, I'm going to create a new file called server.yml. Now this could be called anything you like. I'm going to call it server because it's deploying the server. Now I'm going to name this action deploy server, and I'm going to say on push, and branches is going to be just our main. So when we push to our main branch here, I want to run this GitHub action. And the jobs that I want to run are going to be deploy. So I'm going to say deploy, and then I'm going to specify an operating system to run this on. So I'm going to say runs on Ubuntu latest. Then I need to specify some steps. Before we do that, I just want to set a default, and the default is to run this action with the context of being in this server directory, because that's where we have our Docker Compose file. So I'm going to say defaults, and I'm going to have a default for run, and then I'm going to set the working directory to /server. Okay, so the first step, I'm going to name checkout code, and then this is going to be users actions / checkout at v2. So this is just going to check out the code for us. And then the next action is going to be deploy server. And this is going to use appleboy / SSH action at master. And this reminds me, we actually need to set one more environment variable, and that is going to be our private key. So let's go do that before we forget. So inside of the repository, let's click new environment variable, and I'm going to call this droplet private key. Now these keys that we generated before, I'm going to copy this private one, and I'm going to paste that in as well. And I also want to set the name of the user. So I'm going to set this to droplet user, and then this is just going to be root. So I want to log in as the root user. You probably should create a new user for your GitHub actions, but I'm just being lazy and I'm going to log in as root. Now for this Appleboy SSH action, I need to set some configuration. So I'm going to say with the host, and we actually need to set the droplet host as well. So I'm going to create a new repository secret, and this is going to be droplet host. And I can copy this IP address, put this in. Now I can set my host to $, curly bracket, some spaces, secrets dot droplet host. I can set the username to secrets dot droplet username. I'm going to set the key to some secrets. And I'm going to make sure I get this correct by copying this droplet private key. So now we can start running scripts, and these are just scripts that are going to run on the server. So this module here is going to SSH into our server for us, and then we can run some scripts. So I want to say script stop, and this is going to be true. So as soon as we run into an error, I want to stop the script and I want to fail the action. Next, I can say script. I want to give this a colon and then a pipe because I want to run several scripts. So basically what we're going to do is we're going to replicate our run script that we have. So let's open up this, and essentially we want to do this. So the first thing I want to do is to export my environment variables. So I want to export Upstash Redis REST URI equals $, and this is going to be secrets dot Upstash Redis REST URI. URL, I keep saying URI, and I want to export cause origin, and this is going to equal $, and we have our cause origin stored in secrets. So this is going to be secrets.cause origin. Okay, so now we need to cd into the directory that we've cloned. So we'll come back over to the terminal and we need to cd into this directory here. So in my case, it's called chat tutorial, but it's going to be whatever you call your repository. So I need to cd into that directory, and cd just means change directory. And I want to run git pull. So I want to pull the latest changes. Then I want to run docker compose down. And we actually want to cd into the chat tutorial, and we want to cd into server. So cd server. Now I want to run docker compose up. And I can give this a name. So I can say -- project name, and I can call this chat. I want to run up. I want to run it in detached mode, and I want to build. Okay, so let's commit and push this GitHub action, and then we can go over to GitHub and see it running. So I can say git add dot git commit, and then I can run git push. Because I'm pushing this straight to our main branch, it's going to run straight away. So you can see here we have action. We have an action called deploy, and then it's going to start our job. So this GitHub action is failing on the deploy step. And if we have a look at the error here, we're getting handshake failed, SSH unable to authenticate attempt methods. And the reason for this is because if we go back into our GitHub action, you can see here our username is droplet username, but let's go have a look at the secret to make sure this matches. So if we go back over into settings and we go down into our secrets and variables and actions, you can see that we have droplet user. And so this obviously doesn't match. And so this variable is going to be undefined. So let's copy this and fix the action. So I'm going to change the username to secrets.droplet user, save that, and now I can simply make another commit. So I'm going to say git add dot and git commit, and I'm going to name this fix action. Then I'm just going to push this. So we can go over to GitHub and we can see our actions, and you can see I have this fix action here. And you can see that this error actually took me quite a while to find, which is really annoying. So we can click into the deploy step here so we can get some more details about what the action is doing. So we're getting this error here on line 3, command not found. Now I'm not sure what line 3 is exactly. My guess is that it is either git pull or docker compose down, but we can go into our terminal and we can have a look and try run this manually. So I'm here in the terminal. If you forget how to get here, you can go to access in the DigitalOcean droplet, and then you can open up the console. So I'm going to type ls. You can see that we have this chat tutorial. So let's do step 1 where we try cd into chat tutorial. Let's cd into server. Actually, let's go back. And I'm going to run git pull. And we're already up to date. So git pull is going to work. Let's have a look at the order in which we're doing this. So we need to cd into the chat tutorial, run git pull, then cd into the server. So let's cd into the server now. And let's run docker compose down. And this looks like it's working correctly. We may have just had those commands in the wrong order. We can commit this. So I can say git add dot git commit, fix the action. And then we can push this back up. Okay, so we've pulled one file and we're getting down compose command not found. Well, obviously because down compose doesn't exist. So I've spelt that wrong as well. So this is Docker Compose down. Let's add this, git commit, fix action, and git push. And we can come back to our actions, and then we should see this new run here. Click into here. Okay, so you can see that Docker is doing its thing now. I'm not sure why these lines are prefixed with error, because all of these outputs here look correct. So we're creating the volume and we're setting up our instances, so you can see that our application is building here. We're down to the production stage and we're running npm install. Now our application is being built with TSC. Now we have an image and it should start these images up into containers now. So you can see here it's creating, and we successfully built the application. So let's open this back up again. And we successfully ran all the commands, and you can see here we get this green tick now. Let's go over to Postman and let's try hit our health check endpoint. So our health check endpoint is going to be on https://api.chat.tomdoes.tech/health check. And you can see that we're getting a response back here and it's going through the ports here, which means that it is load balancing correctly. Okay, so for the real test, we need to go to chat.tomdoes.tech and we need to send a message. So hello, one, send this message and we get it back here. Let's open a few windows of this chat just to make sure everything is working as we expect. So hello from client 2, send this message, and they're both connected on port 3001. Let's see if we can get one that is connected on a different port. So I can say, hello from client 3. And this one's connected on 3001 as well. Let's try again. And this one's connected on 4000, and we get this message on all of the clients as well. Hello from client 3, send this message, and we get it on all of the clients. I'm going to leave this up at chat.tomdoestech.com. Please don't spam it, and please don't put anything inappropriate in there. Otherwise, I'm going to have to take it down. So that is how to build and deploy a real-time chat application that's going to scale horizontally with WebSockets and Upstash Redis. Thank you again to Upstash for sponsoring this video. I really appreciate their support for the channel and for the products that they provide. If you enjoyed this video, please make sure you leave a thumbs up and let me know in the comment section below what you're going to be building with this technology. Thank you for watching, and I'll see you in the next video.